Hello guys, in this video we are going to discuss the solution of the problem add 1 to a linked list number. So let us look at the problem statement. The problem statement says you are given a linked list where each element in the list is a node and have an integer data. You need to add 1 to the number found by concatenating all the list node numbers together and return the head of the modified linked list. So for instance, if this is the linked list which is given to us, then we have to add 1 to this linked list and the resultant linked list will be 457 and the head of that linked list, which is 4, is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us take an example. So let us say this is the linked list which is given to us and we need to add 1 to this linked list. So in order to simplify our addition, what we are going to do is the given linked list, we are going to reverse this linked list. So the linked list after reversal becomes this. And once we have reversed this linked list, then we are going to add 1 to the beginning of the linked list. So this becomes equals to 7. Then this remains 5 and this becomes 4. And once we have added it, then we are going to again reverse this linked list. And the resultant linked list will be 4, 5 and 7. And this is what we are going to return. So that's the general idea behind solving this problem, folks. Now let us discuss the pseudocode of this problem. So we want to add 1 to the linked list and a head of a linked list is given to us. So what we are going to do is first we are going to reverse the given linked list. So the linked list which is given to us, we are going to reverse it. Let me go up in order to explain this. So as you can see, the linked list which was given to us is this, and the first thing which we did is we reversed this linked list. So that is what we are doing over here. And once we have reversed this linked list, then we are going to add 1 to this linked list, or we want to increment this linked list. And after incrementing, we want to get our resultant linked list, and the way we will be able to get our resultant linked list is just by reversing the incremented linked list. And towards the end, all we have to do is return head of the linked list. And that's the entire pseudocode for this problem. Now, as you can see, we are using two functions over here, which is reverse and increment. So let us look into reverse and increment function. So first, let us look at the reverse function. So let us say we want to reverse a linked list and head of the linked list is given to us. So we would need some pointers over here. So let us say previous is one pointer which we are using, and then we are going to iterate on the linked list while head is not none. And just like in the reverse linked list logic, so let me explain that. So in order to reverse a linked list, all we have to do is we have to just flip the pointers. So let us say over here it was 1, 2 and 3. All we have to do is the nodes remains the same. All we have to do is we have to flip these pointers. And then this will become our head, and this is what we are going to return. And the way we will be able to flip our pointer is, let us say this is my head pointer and we will have a previous initially equals to none. And then what we are going to do is we are going to save the next pointer. So next equals to head dot next. So what I'm saying over here is next is over here. And once we have saved our next, all we have to do is we have to manipulate our pointers. So head dot next equals to previous. So this is our head dot next pointer, and this we are manipulating this pointer. So since this will become the last element, and the last element next should be equals to none, and that is what we are initializing over here. Initial value of previous equals to none, and that is what it does over here. And once we have manipulated the pointer, then we are going to adjust our previous head and next pointer. So let us do that. So the first thing which we are going to do is previous equals to head. So this pointer becomes previous and the head pointer moves to the next element. So after one iteration, the linked list, this linked list will look something like this. So this is how the linked list will look like. Please note this pointer we have broken it, because of which there is no pointer over here. And let us have the values as well. So this is my previous, this is head, and again the same thing will happen. So the first thing which we are going to do is set our next. So next equals to head dot next, then head dot next equals to previous. So this pointer will be broken, and instead of that this connection will be formed. And then we are going to adjust our previous and head pointer. So the previous will move to this position and head will move to this position. And after that, if we perform the same operation again on this linked list, the linked list will be manipulated something like this. And the previous will be over here and head will become none and the loop will break. So what is the head of the linked list? Well, the head of the linked list will be pointed by this previous, and that is what we are going to return over here. So return previous. So that's the pseudocode to reverse a linked list. Now let us look at the pseudocode to increment the linked list by 1. So let us look at the increment pseudocode. Head of the linked list is given to us. So we are going to use a last pointer as well. So let us have the last pointer and the initial value equals to none, and then a PTR pointer, and initial value is head of the linked list. Then since we are supposed to add, so there will be a carry, and initial value of carry is equals to 0, and we are going to take a bool variable and first equals to true, and then we are going to iterate on the linked list while PTR equals to not none. Now the first thing which we are going to do is if this is the first node. So if this is the first node, then the first will be true, and in such case we have to increase the first node by 1. So let us increase that. So S equals to PTR dot data plus 1. And once we have increased the first node, we are going to mark first equals to false, indicating that the subsequent nodes are not the first node. Otherwise, if this is not the first node, then it is remaining node, and in such cases S will be equals to PTR of data plus carry. And we will see how we are manipulating carry as well. And once we have done this if and else condition, then we are going to update the PTR pointer. So let us do that. Now it might be possible that the sum is greater than or equals to 10. So let us say the linked list is something like 9, 1 and 2, and we are adding 1 to it. So over here, as you can see, this becomes equals to 10. So to handle this case, what we are going to do is we are going to check if S is greater than or equals to 0. If it is greater than or equals to 0, then that simply means carry equals to 1 and sum is equals to sum mod 10. Otherwise, if sum is not greater than or equals to 10, then in such case carry will be equals to 0. And after this manipulation we have our sum. So PTR of data equals to sum, and once we have operated on PTR data, then we have to move to the next element, and before moving to the next element, last equals to PTR and PTR equals to PTR of next. And in this way we have increased our linked list by 1. Now there is just one final case which we have to take into consideration. Let us say the linked list is 99 and we are adding 1 to it. So the resultant linked list will be 100. Now these two zeros will be handled by our inner loop, but this one, which is an extra node, that has to be added into our linked list in such cases. Now the way we will be able to tackle this is if carry exists even after the loop ends, then that simply means there is a need to add an extra element. So let us add an extra element. So in such case, new node will be equals to, we will take a new node and the data of that node will be carry. And once we have this, then we are supposed to add this new node into our linked list. And the way we will be able to do it is last of next equals to new node. And that is the reason we were maintaining this last node. And then towards the end, all we have to do is we have to return our head of the linked list. And in this way, we will be able to increase the linked list by 1. So that's the entire code, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So as we have discussed, the first thing which we are going to do is we are going to reverse the linked list. Then we are going to increase that linked list by 1. And then again, we are going to reverse the resultant linked list. And towards the end, we are going to return the head of the linked list. Now let us look at the reverse function. So in order to reverse the function, we are going to use a previous, which is equals to none. And then we are going to reverse the entire linked list. And in order to reverse the entire linked list, what we are going to do is first we are going to preserve the next element. Then the current element next pointer will be manipulated. Once we have manipulated the next pointer of current element, then we are adjusting our previous and head pointers. And towards the end, we are returning previous. And in this way, we will be able to reverse our linked list. Now let us look at the increment function. So for increment, carry initial value will be equals to 0, ptr equals to head, last pointer equals to none, and first equals to true. Now we are iterating on the linked list. If this is the first pointer, then the ptr data will be increased by 1 and first will be equals to false. If this is not the first pointer, then the ptr data will be increased by carry. And then we are performing this operation in order to obtain our sum and carry. And then the ptr data will be equals to sum, last equals to ptr, and ptr equals to ptr dot next. And in this way, we will be able to increase the linked list by 1. Now it might be possible that towards the end we need to add an extra node. In such case, we are adding an extra node and then we are returning the head pointer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. The first thing which we are doing is we are reversing the linked list, then we are increasing it by 1, and then again we are reversing the linked list, and towards the end we are returning the head pointer. So let us look at the reverse function. For reverse function, previous equals to null, and then we are iterating on the linked list. We are preserving the next element and then we are manipulating the current next pointer. And after manipulation, we are adjusting our previous and head pointers. And towards the end, we are returning previous. And in this way, we will be able to reverse the linked list. Now let us look at the increment function. So to increment, we will need a pointer. An initial value of pointer will be equals to head, last equals to null, carry equals to 0, and first equals to true. Now we are iterating on the linked list. And if this is the first node, then s equals to ptr of data plus 1 and then first equals to false. Otherwise, s equals to ptr of data plus carry. And then with this if and else condition, we are adjusting our sum and carry. And after adjusting our sum and carry, we are putting that value into ptr of data. And after that, last equals to ptr and ptr equals to ptr of next. Now, it might be possible that we might have to add a new node. In such case, the new node will be added. And the way we are doing that is last of next equals to new node. And towards the end, we are returning head of the linked list. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.